Hello, good evening. Am I audible? Hello.
Yes, sir.
Okay. Actually, my network connection is not much stable. So, if you find any difficulty in hearing me, then just let me know. Okay.
Okay, sir.
Okay. Okay. So then let's start. So let's move to the first question of today. So this is the question number 50 of GATE 2014 Metallurgical Engineering. So the question is two phases alpha and beta are in thermodynamic equilibrium if x and y are the only components present in the phase alpha and beta, and if mu I j represent the chemical potential of component I in phase j, then the condition for equilibrium is option A, mu x alpha is equal to mu y beta and mu x beta is equal to mu y alpha. Option B, mu beta x is equal to mu alpha y and mu alpha x is equal to mu beta y. Option C, mu x alpha is equal to mu x beta and mu y alpha is equal to mu y beta. And option D, mu x alpha is equal to mu y alpha and mu x beta is equal to mu y beta. So, do you want to approach how to solve this question?
I think it's A, sir.
Option A, you mean mu x alpha is equal to mu uh, y beta. Mu x alpha means chemical potential of x in phase alpha, is equal to
Yes, sir.
chemical potential of Y in phase beta. Is it? Okay,
Yes, sir.
before approaching it, just can you just tell me what is the definition of chemical potential, or what is the chemical potential? You can
Chemical potential means the phases present in component are in chemical equilibrium at any I mean, like wherever we take the composition, the alpha and beta phase of X and Y components are in equilibrium.
know. I asked that chemical potential. What does it mean? Chemical potential means what? You can state in the mathematical term also. How you will write chemical potential? Let's say mu. How you will write it in terms of this in mathematical terms? Do you know it? Do you know this equation? dg by dn
Ah, yes, sir. I know that, sir.
constant temperature and pressure, right? So if it is mu I or mu then it will be dni. Now all the other component will be constant. Let's say j and all. Okay. So if you state in a statement, the definition of the chemical potential will be at constant temperature and pressure, the change in free energy for 1 mole addition of that element in the system. Change of free energy of the system at constant temperature and pressure. Change of free energy system per mole addition of. So let's say you have a system of A and B, or let's say X and Y. Okay. Now you add 1 mole of X in this system, 1 mole of X. So now let's say initially its free energy was G1. Okay. And after addition of 1 mole of X, its free energy will be G2. Then chemical potential will be G2 minus G1. And dni means it will be 1 here, because 1 mole of X you are adding. So remember that free energy change of the system you have to write G2 minus G1, not the free energy change of that particular element on. Okay. So if you add 1 mole of X, then what is the free energy change of the system? How much the free energy change of the system per mole of addition of that element? That is known as chemical potential at constant temperature and pressure. Okay. So
Okay, sir.
yes, do you have any doubt?
No, sir.
Okay. So now G is a function of what? Temperature, pressure, and number of moles.
Number of moles.
Right. Now, if you
Yes, sir.
write it in terms of differential term, then it will be dg is equal to del g del t at constant pressure and number of moles into dt, right? Plus del g del p at constant temperature and number of moles into dt, plus del g del n at constant temperature and pressure. Now, what will be the this term? dg by dt is dg by dt at constant pressure and number of moles. It is minus s, right? You know, right? That Maxwell equation dg equal to g dt
Yes, sir.
minus s dt, right? Now, if the pressure is constant, that means dp is 0. So then dg dt at constant pressure will be minus s, right? From this equation you will get it. And similarly, dg by dp del g by del p constant temperature will be what? V, right? So here we can write that this term will be minus s and this term will be v, and this sorry, there will be dn, and this term is mu. Okay, just now we understood the definition of mu. Mu is dg by dn at constant temperature and pressure. So this will be mu. Okay, sorry, screen is visible, or I think that
Visible for first slide, like
first slide
start.
only.
Yes, yes. Now visible, sir.
Yeah, actually my network is very slow. That's why it is happening. Okay. So now we can write dg is equal to minus s dt plus v dp plus mu dn. Right. Now here it is mentioned that the two phases alpha and beta are in thermodynamic equilibrium, and if x or y only the component present. So now thermodynamic equilibrium means at constant temperature and pressure. So then it will be dg is equal to mu dn. Right. Now let's say this is our system. So two phases is present. Let's say this is one phase, phase 1 and phase 2. Okay. So in this phase 1, let's say phase 1 is alpha and this is beta. Okay. So mu x alpha means chemical potential of x in alpha, and mu y alpha means chemical potential of y in alpha. Similarly, mu x beta means chemical potential of component x in beta phase, and mu y beta means chemical potential of component y in beta phase. Okay. Now if you write this equation in terms of mu x and mu y, then what you will get, I am going to the next page. Okay, so we got this equation dg is mu into dn. Okay, so now we have two phase, one is alpha, one is beta. So mu x alpha here, mu x beta here, and mu y alpha here, yes, and mu y beta. Okay, so now I am writing in terms of that component. So dg x will be mu x alpha dn x. Okay, and dg x in beta will be mu x beta into dn x. Right. So for x component only I am writing. So it will be for the alpha phase, the dg will be dg x alpha will be mu x alpha into dnx, and dg x beta will be mu x beta into dnx. So now if it is in equilibrium, the free energy in the both sides should be similar, right? The free energy should be equal. So that means
Yes.
dg x alpha minus dg x beta will be 0. The change in free energy will be 0 at equilibrium for two phases. Then only it will be under equilibrium. So and no transfer of that element will be possible. So now if we write this dg in terms of mu dn, we will get mu x alpha dnx minus mu x beta dnx is 0. If you take dnx common, then it will be mu x alpha minus mu x beta into dnx into 0. Now dnx is not 0, non-zero term. So as dnx not equal to 0, so what will be, so equation will be mu x alpha minus mu x beta will be 0. So mu x alpha is equal to mu x beta, right? Is it clear up to this?
Yes, sir. Sir, but you write dnx is not equal to 0.
Yeah, dnx is not equal to 0 means this is a binary system, right? So
Yes, sir.
it is mentioned that if x and y are the only component present. So let's say this is our system. In this system, x and y is present, and dnx is what? Number of moles or mole fraction of number of mole of element x. If element x dnx is 0, that means only y is present, right? That means it is a pure component. It is not a binary system, right?
Yes, sir.
If dnx is 0, then dny will be 1, right? So that means it will be only pure y. Okay. So if dnx is 0, then you cannot write this this one is equal to 0. You can only cancel this term when this term is a non-zero component, right? This is a simple mathematics. Okay.
Okay,
So
sir.
do you have any doubt up to this?
No, sir. Clear, sir.
Okay. So similarly, if I write in terms of component y, then also it will be what I, let's say, component y, mu y alpha, dn y, and pgy beta, mu y beta, dn y. So similarly, if we do like this, or if we similarly that for component y also, the free energy will be same, right? If it is under equilibrium, that means dgy in the alpha phase is equal to dgy in the beta phase. At equilibrium, the free energy of component y in the alpha phase is equal to the free energy of the component b at beta phase. Then only it will be under equilibrium. So similarly, from here also we will get mu y alpha is equal to mu y beta, right?
Yes, sir.
Are you getting why the free energy of component will be same in the two different phases? Which is under equilibrium, and let's say this is the interface. So we have component x and component y this side, component x and component y this side. Okay. Now the concentration may be different, but no, so you may think that as the concentration is different, then there may be a transfer of x from this side to this side, or transfer of y from this side to this side. But this will not happen because the free energy of component x in this side is equal to the free energy of the component uh, x in the that side, means in the alpha phase is equal to the free energy of component x the beta phase. So for a particular component, that free energy should be equal. Then only transfer of x from this side to this side or this side to this side will not be possible. Okay. So if we equate this two free energy, we will also find that the mu y alpha is equal to mu y beta, and mu x alpha is equal to mu x beta. So that means free energy of component x at alpha phase is equal to the free energy of component x in beta phase. And okay. And by simplifying this equation, we will get that chemical potential of component x in alpha phase will be equal to the chemical potential of x in the beta phase. So then which will be the answer, correct answer? Which option is the correct?
Option C.
Option C, right? It will not be
Yes, sir.
option A. Option A means chemical potential of x. So how chemical potential of x will be equal to the chemical potential of y, right? Chemical potential of
Yes.
x in the both sides should be similar. Then only there will then only it will be under equilibrium. In the both side, chemical potential of x will be equal and chemical potential of y will be equal. Okay. Do you have any doubt?
Clear, sir.
Mhm. So then Should I move to the next question?
Okay, sir.
Okay. Uh, so this is the question number 53 of GATE 2014 Metallurgical Engineering. The question states that the specific heat Cp of pure iron expressed in joule per mole per Kelvin as a function of temperature T in Kelvin is given as Cp is equal to 17.49 plus 24.77 into 10 to the power minus 3 T. What is the change in enthalpy of pure iron when it is heated from 25 degrees centigrade to 700 degrees centigrade? So, anyone of you want to approach how to solve this?
I
CP,
didn't get you, sir.
yes.
We have to use entropy equation like and delta is equal to T1 to T1 integral T1 to T2 CPDT by T.
Delta S equal to delta S or delta H.
Yes, sir.
Enthalpy it is mentioned here. You have to calculate the change in
Yes, sir.
uh, yes. You have to calculate the change in enthalpy, which is not delta S. You have to calculate delta H, right?
Okay, sir. Clear, sir.
Yeah.
Overflow.
So first, uh, can you express what is Cp? What is specific heat at constant pressure?
Amount of heat required to raise the substance by 1 degree Celsius, sir.
Yes, at constant pressure, right? So that means if you write in the mathematical form, it will be amount of heat that is delta Q is required to raise the temperature 1 degree at constant pressure, right? Now, uh,
Yes, sir.
at constant pressure, this delta Q is equal to dH or change in enthalpy. So then this equation will become Cp is equal to dH by dt at constant pressure. Now, do you know why this delta Q is dH at constant pressure? Why? Why can we can replace delta Q with dH?
Internal energy equal to 0.
Okay, but can you express in the mathematical term how internal energy will be? Always systems will have some amount of internal energy. The change of the internal energy may be zero during different process or something, but the total internal energy of a system will be always positive. Means always a system have some amount of internal energy. Okay, do you know the first law of thermodynamics in the mathematical form? Can you just express it? First law of thermodynamics.
dq equal to du plus tw.
Del Q is equal to du minus del W. This is minus because there is a different sign convention. If the work done by the system is negative, if the system is doing work means your system is losing some energy, right? So then it will be
Yes, sir.
negative. Or you can write this delta W in terms of PdV. So du minus PdV. So if the system is doing some work, then it is positive. Sorry, negative. System, and if the work done on the system, then it is positive, right? System is doing work means it is losing some energy. That means its internal energy will drop. Okay, you can remember like this. Whenever the system is doing work, that means it is losing some energy from the system. So that means it is negative. If you are doing some work on the system, then you are storing some energy on the system, right? So then it will be positive. Similarly, delta Q, if the system is releasing heat, then it is minus. If the heat is you are giving heat to the system, then it is plus. Okay, and similarly du also. So now this is delta Q. Del Q is du minus p dv. Okay. Now, what is enthalpy? How we write enthalpy? H is equal to
H is equal to U plus PV.
dv, right? If you differentiate, dh will be du plus p dv plus p dt, right?
Yes, sir.
Okay. Now, at constant pressure, system will be 0. It will be dv plus p dv. Okay. So now, there will be okay. Uh, It is because of the sign convention. Actually, in few books you will find they use plus here, and few books you will find that they use minus here. So this is because of the sign convention only. So you have to follow only one sign convention. So here you can write in terms of plus, and dv means then if the system is doing that time you have to put negative here. If the work done on the system that time you have to put positive here. Okay, you have to follow the sign convention like this. So now uh, here you can write just du plus pdv is what? Delta Q, right? At constant pressure only. At constant pressure this term is 0. If the pressure was is not constant, then this term will not be 0. Okay, then you cannot write dh is equal to delta. Are you getting it?
Yes. Yes, sir. Getting.
Okay. Okay. So now we know that we can write Cp in terms of delta H and delta P at constant pressure, right? Now Cp is Ph at dt. So now if we bring dt in this cycle, Cp dt. Now if we integrate, what is the temperature range? From 25 degrees centigrade, that means
700.
298 Kelvin. 700 degrees
700.
centigrade means 973 Kelvin, right? So 298
Yes, sir.
Kelvin to 973 Kelvin. Similarly, this side 298 Kelvin to, okay. That means H at 973 Kelvin minus H at 298 is equal to integration of Cp means Cp is given here the expression 17.49 plus 24.77 into 10 to the power minus 3 kilo. 17.49 plus 24.77 to 10 to the power minus 3 T into dt, right? So this will be delta H. It will be 7 17.49 T plus 24.77 into 10 to the power minus 3 into T square by 2, from 298 Kelvin to 973 Kelvin. Now we can write. Can you calculate this one and let me know the answer?
Yes, sir.
How much you are getting?
Calculating, sir.
Okay.
Sir, I'm getting
Yes.
22437, sir.
22437. Okay.
Yes, sir.
So I am getting 22431. Okay. Let me recheck once again. 17.49 plus 24.77. 21 minus 3. Okay. Are you taking this 973 only, or you are taking 973.16?
Sir,
Uh, are you taking this?
973 only, sir.
Okay. So I'm getting 22,431.15. Can you recheck once again?
Okay, sir. Sir, up to what decimals did you take, sir?
Uh, Only two decimal is fine. Or anyway, means in this numerical answer type question, they have some range of means if your answer is from this range to this range, then you will get the marks. So you are getting 437, right? So this is very close answer. So you need to worry. But from this, if you take 17.49 up to 2 decimal only, I think you will get this answer. I'm not sure, but I calculated also, but both of the times I got this answer only. This is 17.49 into 973 minus 298 plus 24.77 into 10 to the power minus 3 into 973 square minus 298 square by 2. Are you
Yes,
doing the
sir.
same?
Same.
Okay, no
Yes,
need
sir.
to worry if you are getting this 437 because this is very close one. So I think in the questions means the range of the answer is 22,380 to 22,450 or like this. It was there. I didn't remember the exact answer, exact range, but it was like this only. So you are very close to this. So no need to worry for this. But uh,
Okay, sir.
did you get that concept? How we are calculating this one? So this is the important.
Yes, sir. Getting, sir.
Okay. So, what is the change in enthalpy of pure iron in joule per mole? You have to keep in mind the unit also. If sometimes they may ask in the kilojoule per mole. Okay, that time you have to write 22.4. But they ask in joule per mole, so the answer will be 22,431.15 joule per mole. So you have to be very careful with the units also. Okay.
Okay, sir.
Now, can you just plot the H versus temperature? Do you know the plot? How the H varies with temperature, how the entropy varies with temperature, and how free energy varies with temperature?
Actually, don't know, sir.
Okay. Okay. How entropy varies? Like entropy increases with temperature or decreases?
Increasing.
Entropy increases with temperature. Entropy always increases with temperature. Right? So let's first start with the entropy. So the entropy initially it varies like this, and then increases and it gets saturated. Yes, it will not get saturated like at the higher T it will increase at very slow rate. Okay. So this is the how entropy varies. And G is H minus T delta S or delta S minus H minus Ts. Okay. I we are writing the absolute value. Let's say G is H minus Ts. Okay. Now let us see how H varies with temperature. What is what is H? What is enthalpy? E plus
Heat content.
Mhm.
Yes, sir.
Okay. So H means, or you can understand from this equation or this equation. H means total energy content of the system. Okay. Total energy of system. So sum of it is associated in terms of internal energy, and sum of this is associated with the free energy or available energy to do work. So the system has two type of energy. One is associated with the internal energy. This is because of the bonding, vibration of the atoms and all this kind of thing. some energy is associated which you cannot use for to do some work. So that much of energy is internal energy, and some of energy is there which can be available to do some work, that is PV. So H is total energy. Now, if you increase the temperature of a system, what what will happen to the atoms? Atom will vibrate very randomly, right? So vibration
Yes,
energy
sir.
will also increase. Okay. So, and also means so that means the internal energy of the system is increasing as you increasing the temperature, right? So vibration energy increase and other many other factors are there. So if you just think in the simple term, so you can just you can identify that if you increase the temperature, the energy of the system will increase. It will not decrease, right? So it will go to the higher
Yes,
energy
sir.
state, right? So one is because of the internal energy of the system will also increase, because as you are heating, the atoms will vibrate more randomly. So the vibration will also, frequency of the vibration will also increase. For that reason, you will also increase. So your enthalpy with temperature will increase, and generally people set a reference value at 298 Kelvin. At this point, enthalpy is zero. It is generally considered at 298. Enthalpy is zero. So this is a reference value. Okay. So now enthalpy is increasing with temperature and S is also increasing. Okay. So now how the G will vary with temperature. So from this equation also you can say this is like what will be the slope first? Tell me. G versus T. If you plot, what will be the slope? Slope will be delta G by delta T, right?
Yes, sir.
So this will be minus S.
Minus, yes.
Okay. This will be S. So slope is minus S, and S is positive. S increases with temperature increases. So that means G, the slope is negative, right? Negative slope means G will decrease with temperature, right?
Yes, sir.
So that means at T equal to 0, G will be H, right? So if
Yes, sir.
so here it will be H, from here it will decrease, right? Because your slope is negative.
Okay.
Yeah. So similarly, Cp also varies with temperature like this. Cp varies with temperature almost similar to the uh, entropy, almost similar behavior it finds. Sometimes, for the sake of simplicity, the Cp people give in terms of A plus Bt term. In this problem, as we see, that Cp is A plus Bt. That means it is a straight line equation, right? So generally, this part it almost follow the straight line and then it gets saturated over here. Okay. So for our problem, the CP curve was straight line A plus BT. Okay. It was like this.
Mm.
No. And suddenly, if your phase changes from let's say solid to liquid, let's say this was solid and then suddenly liquid, then your CP will jump at the melting point. That means at melting point, sorry, this will be Tm. Similarly, the entropy and G also, entropy and enthalpy also. So now are you getting how you are getting this plot? Sometimes it is
Yes, sir. Got it.
important to understand how the different terms are varies with temperature, because mm, when you will go for the
Sir, once explain H
yes,
versus T, sir.
yes,
Once explain HT curve, sir. H versus T curve. Enthalpy versus temperature.
H, right, this one. How?
Yes, sir.
Okay. H means enthalpy means that the total energy which is associated with the system. So what is free
Sir,
energy?
then
Yeah,
we
yeah.
understood that, sir.
Okay.
But how
How?
it is coming from negative axis, no, sir? How? Why negative? It
This
coming
is
from down.
this is generally people take this at 298 as reference value. So that's why people
Mm.
consider 298 as the reference one, and it takes it as zero. Okay, because at the means lower temperature or this you cannot measure the absolute value of the enthalpy. You can only measure the change. You cannot measure the absolute one, right? Means what is
Yes,
the
sir.
absolute value of the enthalpy that you cannot measure? Okay, so for that, people generally take 298 or room temperature as a reference value, and then what how much change you are getting as you are going above temperature or below temperature. Let's say uh, this is the room temperature you are taking as reference. So at room temperature you take delta H or H absolute value of H as zero. Okay, because experimentally you cannot determine the absolute value of H. You can determine the change. So you take a reference frame at T equal to 98 Kelvin, and you assume that at H is zero at room temperature. Okay. Now, if you go below the room temperature, what will be the change of your H? It will decrease, right?
Yes, sir.
Because you are decreasing the temperature. If you are increasing the temperature, the your H will increase. If you are decreasing the temperature, H will decrease. So people generally set the reference zero at room temperature, and then from room temperature, if you are going down, that means your enthalpy is decreasing. That means H2 minus H1 will be negative here, right? Now H1 means at room temperature, that is zero. That's why people take H2 as negative. But actually your system will have some amount of energy, so it will not be positive. But as you cannot calculate the absolute value of the enthalpy, so you have to take some reference value, then only you can measure from that level. Let's like the height of the Mount Everest or height of any mountain, you measure from the sea level, right? So
Yes, sir.
it is above sea level means positive, it is below sea level means negative, like this only people measure. So similarly,
Okay.
here also, is your reference room temperature is zero here, and if you are going upwards means positive, if you are going downwards means negative. This is not absolute value of H, but as because of the reference, people take it like this. Okay,
Yes, sir. Clear, sir.
okay. So now should I go to the next question? Everything
Yes,
clear
sir. Sure.
from this question?
Yes, sir. Clear, sir.
Okay. Okay, now let's move to the next question. It's the question number 34 of GATE 2014 Metallurgical Engineering. The question states that an electrolytic refining cell for copper consists of an alloy with activity of copper is equal to 0.8 as the anode and pure copper as the cathode. What is the absolute value of the cell potential in millivolts at 25 degrees centigrade, given that copper is divalent? Faraday constant is 96500 coulomb per mole, and the universal gas constant is 8.314 joule per mole per Kelvin. So you are doing electrolytic refining. So it is mentioned here you are using pure copper as the cathode, and alloy of a copper which activity is 0.8 as the cathode. Sorry, as the anode. So this is anode and this is cathode. Okay. So anode you have copper alloy, and here you have pure copper. Where activity of copper is 0.8, and you have some electrolyte in this chamber. Okay. Now, can you write the half cell reactions for this electrolytic refining? What is happening basically?
No idea, sir.
Where oxidation is happening where reduction is taking place.
At
I mean,
anode, oxidation takes place.
anode oxidation. Okay. First,
Hmm?
let us
I think cathode oxidation.
no, that confusion many times people do. Sometimes people say at anode, sometimes at cathode. But if you just see the problem itself, then you can find out that you are doing electrolytic refining, right? So electrolytic
Yes, sir.
refining means what? You have some copper alloy over here at the anode. Okay, this copper plus impurity. So you are doing refining means what you are doing basically, and here you took some pure copper. This is pure copper cathode. Now refining means only copper will dissolve from here as U plus 2 ion. It will travels through the electrolyte. It will go to the cathode, and here it will deposit as copper. Right. So after some times, if your cathode was thin, as you do the electrolysis, your cathode will become thick because copper from the anode, copper will dissolve and it will come to the cathode. So at cathode, it will be deposited as pure copper. Refining means like this. So if you don't know where which reaction is taking place, just see what is happening to your system. Are you getting what is refining? Electrolytic refining means
Yes, sir.
you
I
know
have.
it, right? So
Yes, sir.
yes. So one side there is copper plus impurity. So copper is dissolving from here. Refining means now it is going through the electrolyte and it is depositing on the cathode. So after sometimes your cathode will thick, means it will be thickening of the cathode will occur, and anode will uh, it will be thinner and thinner, and at the end there only impurity will be present in the anode, and all the copper ion will be dissolved here. So now this how much tendency up to how much the reaction will occur, that will depends on the equilibrium conditions and all. Okay. So now you know the what are the reaction occurring here. So now if I tell you to write the equations, now you can write, right? So at anode, what is happening? At anode,
Copper is
copper is
getting.
dissolving. So that
Yes,
means
sir.
copper, you have copper in the atomic form. Now it is going as a ionic form, right?
Yes, sir. Cu 2 plus 2 electrons.
Yes, it is divalent mentioned here. So this is at anode. The reaction is Cu is equal to Cu2 plus 2 electron, and this is copper impure because copper plus some alloy is there, right? And now, which reaction is happening at cathode?
Copper is coming and depositing.
That means Cu2 plus is depositing, is taking electron from the cathode. Because cathode is negative here, and anode is positive here. So that means electron is there. So it is taking electron from the cathode, and it is getting deposited as copper in the pure form, right? No impurities there.
Yes, sir.
So this is your anode half cell, and this is your cathode half cell. Okay. Now if you write the total reaction, it will be simply copper from impure to copper to pure. Okay.
Yes, sir.
Now if you write the delta G of this equation, for these two equation you can write the delta G also. So what is delta G? delta G for anode is equal to delta G naught minus RT ln K. K means here it will be activity of Cu2 plus by activity of copper impure, right? And similarly here delta G of cathode will be delta G naught of cathode minus RT ln activity of copper pure by activity of Cu2 plus. Okay, now what will be the delta G for the cell? The total cell, these are the half cell reaction and this is the cell reaction, right? This is the cell reaction, copper impure to copper pure, right? So now
Yes,
you
sir.
can write delta, I'm going to the next case. Delta G of the cell is equal to delta G naught of the cell minus RT ln Q. Q means, or RT ln K means the equilibrium constant. Okay, if it is under equilibrium then it is K, or if it is not at equilibrium then you have to write in Q. Okay, so minus RT ln Q means what? Q means or K means here copper, activity of copper pure divided by activity of copper impure, right? Activity of copper
Yes, sir.
pure
Pure
divided by
by
the activity of copper impure.
impurity. Mm.
Delta G cell. And delta G for cell reaction you can write in terms of number of moles and Faraday constant, and E is equal to NF V naught cell. So electrolysis delta G is NF into your E, is the voltage value. So
N means number of moles, no, sir?
yes, number of moles of that is electron. How much number of moles of electron is given. So in this case, the 2 it is charge, number of moles of the charge particles, or ion, number of moles of the. So here number of moles of the charge is 2. Okay. Now at equilibrium your delta G cell will be 0. So that means this part will be 0, right? So this will be minus RT ln. Now activity of pure copper is 1, right? Activity of any pure component is 1 and activity of
Okay,
impure
sir.
is 0.8. It is given to us, right? Now
Yes, sir.
we can calculate unit cell. Unit cell is RT by NF ln 1 by 0.8. This is also called as Nernst equation. Have you heard about it?
Yes, sir. Similar to the.
Yes. So this is Nernst equation. So if you know the equation directly from this equation, you can calculate. You don't need to write all these things. Okay. So now all the values are given to us. R is 8.314 into T is 25 degrees centigrade. Right? T is given 25 degrees centigrade and the activity was also given. F is 965 96500. Okay. So just put the value here. So T is 298 Kelvin. Number of moles is 2. Just 2 moles of electron. Copper is divalent. So 2 moles of electron is associated with this reaction. And F is 96500 into ln 1 by 0.8. Can you calculate and let me know the answer?
Yes, yes. 1 minute. Sir, I'm getting 0.002, sir.
0.00286, right?
Yes, sir.
This is in volt. Okay, so
Yes, sir.
you have to write the answer in millivolt. Okay, it is mentioned what is the absolute value of the cell potential in millivolts. So this is in volts, so that means it will be 2.86
2.864
millivolt.
millivolts. Okay, sir.
The correct answer is 2.86 millivolt. Now you understand?
Yes, sir.
You
Clear,
have
sir.
any doubt?
No, sir. It's clear.
Okay. Now, by seeing the half cell reaction, can you tell me where the oxidation is taking place and where the reduction is taking place?
At anode reduction, sir.
Anode reduction. Reduction means what? Your
Removal of electron. Like,
no, your means valence means charge uh, charge number. Here it is zero. Here it is plus two. It is increasing means oxidation, right? If it is decreasing means reduction. Am I correct?
okay, we have to calculate on the ions. Okay, sir.
Yeah, means your that number is what to see. Like if it is an pure state, that means it is zero means, and it is becoming plus two here. So
Yes, sir.
it is increasing means oxidation is taking place, and
Yes, sir.
from plus two
E-
to it is going to zero. This reduction is taking
Zero.
place at that.
Reduction. Yes, sir. Now I got it, sir.
Yes, yes. So sometimes your anode may become positive or cathode become negative, or sometimes cathode may be positive and anode may be negative. So that in this case it is refining is taking place here, but in case of charging the battery or electrolysis, in case of electrolysis, this scenario will be opposite, and that time your anode will be negative and cathode will be positive. Okay, so yes, we have to see the reaction, how the reaction is taking place. Then only we can understand where which reaction is taking place. If you know the process, now here if you think that anode, the anode reduction is taking place or oxidation is taking place, you will get confused. But if you know how the electrolytic refining works, then you can simply write the reaction and then you can see where oxidation is taking place, where reduction is taking place, and simply you can write the delta G and Q value. If you don't have any background uh, of this, like you forgot everything, but if you know follow the simple concept and
Voicing, sir.
yeah, so then you can solve the question, right? So in gate you have to approach like this. First you have to solve the question which you are confident enough, so quickly solve those questions first, and in which question you are not that much of confident, but you have or you know the concept, then you can take some times to solve this type of question, and you can simply, let's say you forgot everything how the which one in which
Sir, your
yeah, my okay, voice is breaking. Now you can hear me or
like suddenly it coming and suddenly it going off, sir.
okay, okay. Actually, the network issue is there in this side. So I think. So do you have any question? Means any doubt? Or you want me to explain anything else?
No, sir. For now, the questions are very clear, sir.
Okay. So all the three questions are clear. Then the first
Sir,
one,
how to
yeah.
sir, how to approach problems, sir? I'm very weak in solving.
Okay. That first you go for those problem in which you are confident enough, or you can solve this question very quickly. Okay. Some so first. In dates, I think if you calculate the average, I think you will get around 2 to 3 minutes for each question, right? So from that,
Yes, sir.
few of the question you can calculate within 1 or 1 minute itself. Okay, just save that time for the rest of the question in which you are not that much of confident. So for those type of
Mm,
question, like let's say in this case in electrolysis, you don't know earlier and which cell which reaction is taking place. Okay, in anode which reaction is taking place or in cathode which reaction is taking place. So, but you know the how the electrolytic refining process works. Refining means from impure you are getting something pure, right? This is a simple concept. So now from this you can implement that concept and you just read the question properly. If you read the question properly, everything is mentioned here. The pure copper is at the cathode side, your impure copper is at the anode side. Now from impurity to purity it is going means. So if you read the question properly, you can simply write this kind of equations and then you can go step by step. Let's say you forgot everything, you don't know where the oxidation is taking place. Because if you see the Nernst equation, I think it is written in terms of this. E is equal to E naught cell minus RT ln activity of the reduction by activity of oxidation, right?
yes, sir.
Yes. So if you know just this question this equation only, now you will get confused where the oxidation is taking place, where the reduction is taking place, right? But if you remember this thing, in electrolysis where the oxidation and where the reduction is taking place, if you are confident enough, then you can directly go by this equation and you can solve the question using this equation only. So it will not take much time. Okay, but if you are not confident, so first you go for those questions in which you are confident enough. Okay, and take or save some time for this kind of question. Then you just write the equation step by step so that you don't do any mistake. Okay, and then you can easily solve what are the data from the given in the question. You can take some time for writing the equation and then you can solve. So only you answer this question, right? I have just guided you, right?
Sir?
Yeah. Is this, am I audible?
Yes, sir. No order, sir.
Yeah. So this question, when I asked you, you didn't know which reaction is taking place where, but when I guided you, only you solve this question, right? You take, you told me which reaction is taking place at anode, which reaction is taking place at cathode. Okay. So if you think properly, even you can easily solve this question. If you don't have any background or if you forgot this thing, but if you have the concept, you can solve this question. Are you getting? Hello.
Yes, sir.
Okay.
Yes, sir. Clear. Mhm.
Okay. Oh, and you practice some problem and all, so then you will get much more confidence. Like you have to also increase your speed, right? So you practice some problem from some different books or some question bank or like this. So as much as question you will solve, you will get much more confident. Hello. Hello.
Yes, sir. Now I can hear you.
Oh, okay, okay. Actually, network connection is too poor here. Okay, then do you have any other question?
No, sir. Now clear.
Okay, then we'll meet on the next Friday. Okay. So on the next Friday also
Okay,
I
sir.
may solve some problem related to the thermodynamics and some one problem will be there from the XRD. how to determine the lattice parameters from the XRD peaks. So this concept I will
Mm.
cover. Okay. So if you want to read those concepts beforehand, then it will also maybe easier for you also. Okay.
Okay, sir.
Okay, then
Thank,
we'll meet on the next video. Okay.
thank you.
Thank you.